In this problem, a function f is given such that it satisfies f of x plus y will be the product of fx and fy, where x and y all belongs to natural number. Again, they give f of 1 is equal to 3, and the summation of fx from 1 to n is 120. And they ask us to find the value of n. So let's start. First, we try to write down all the given information. Given function f of x plus y can be written as f of x, f of y, and f of 1 is given as 3, and summation of fx from 1 to n is 120. Let's try to write f of 2, which will be, it can be written as f of 1 plus 1. Again, which can be written as f of x, f of y in this form. Now we will put the value of f of 1, that is 3 into 3. It will give you 9. Now we will find f of 3. It can be written as f of 1 plus 2, which again can be written as f of 1 into f of 2. So 3 into, and what we got here in f of 2, 9. So 3 into 9 will be 27. We will do one more, f of 4. It can be written as 1 plus 3 or 2 plus 2, whatever you can write. Now it can be written as f of 2 and f of 2, which will be 9 into 9 equal to 81. Here we can see that f of 2 by f of 1 is 9 by 3, which is again 3, and f of 3 by f of 2 is equal to 27 by 9, which is again 3. Thus, there is common ratio r equal to 3. Now we can say that f of 1, f of 2, f of 3, and so on, they are actually making adjective are in G. Now is given that summation of fx from 1 to n is 120. Now this summation can be written as the formula of summation of a GP. So Sn gives the formula where A is the first term and R is the common difference. So first term here is actually 3, which is F1 given. And what we get R as 3. So 3 to the power n minus 1 and 3 minus 1. On simplifying, you will get 40, and 2 multiplied you will get 80. So 3 to the power n is equal to 81, which can be written as 3 to the power 4. So now we have same base, so we can say that power is same. So n equal to 4.